Yeah, good day everyone. In this tutorial video, we are going to learn about inorganic chemistry. Inorganic chemistry is an important aspect of chemistry. Chemistry is very wide. We have different aspects of chemistry. We have organic chemistry, we have inorganic chemistry, physical chemistry, environmental chemistry, theoretical chemistry, medicinal chemistry, and so on and so forth. Now we want to focus our attention on inorganic chemistry. Inorganic chemistry is an aspect of chemistry that can be said to be the opposite of organic chemistry. Inorganic chemistry focuses on the what? On the chemistry of the elements in the periodic table. The periodic table of elements is very, very important, and that is our focus for today. The periodic table. The periodic table of elements. It was Ivanovich Mendeleev, a Russian chemist, that constructed the periodic table. The periodic table of elements contains families of elements. All the elements that we deal with in chemistry, they are all from what? From the periodic table. Periodic table contains elements: hydrogen, helium, lithium, beryllium, boron, carbon, and so on and so forth. All of these elements are in the periodic table. The periodic table, in the periodic table we have 8 groups, or call it columns. There are 8 groups or columns in the periodic table. All of this group will be analyzed very, very soon. And we have 7 periods, or call them rows, in the periodic table. There are 7 periods, rows of elements in the periodic table. Then there are 7 main groups. 7 main groups of elements in the periodic table. There are 7 main groups, or let us say there are 7 main categories. I call it categories of elements in the periodic table. Now we want to look at all these one after the other. We said we have 8 groups and 7 columns of elements in the periodic table. Now this is the periodic table. We have hydrogen here. Hydrogen, helium, lithium, beryllium. Okay, let's say we have boron here, boron, carbon, nitrogen, oxygen, fluorine, neon. Definitely helium will be here. Helium will be there, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. After sulfur we have chlorine, argon, potassium, calcium. These are the first 20 elements in the periodic table. Now we say we have 7 rows, otherwise called periods, in the periodic table. And we have 8 groups. There are 8 groups of elements. Okay, we have this. These are the groups. Group 1, 2, 3, 4, 5, 6, 7, 8. Those are the columns. We have 8 columns. And we have 7 rows. 4, 5. There is actually another row there. 6. And another row here. So definitely we can say there will be another row here, another row here, another row here. And okay, 1, 2, 3, 4, 5, 6, and 7. Those are the 7 rows of elements that we have in the periodic table. Fantastic. Now we also mentioned that we have 7 categories of elements. The first category of element that we have is hydrogen. Main categories. Hydrogen is taken to be a particular category of elements in the periodic table because hydrogen is the first element in the periodic table, and hydrogen as an element can also fit into more than one group. Hydrogen is placed in group 1 simply because hydrogen has one electron in its outermost shell. And hydrogen can also fit in another group, and which is what? Group 7. Simply because hydrogen requires one more electron to complete its outermost shell, just like every other element in group 7. Then the other categories of elements that we have are what? Are the metals. The metals, those are the elements that occupies the left hand side of the periodic table. That is group 1 and group 2. Group 1 elements are otherwise known as, okay, let's have this. Group 1 element, we can also call group 1 element alkali metals. While group 2 elements can also be called alkaline earth metals. So these 2 groups of elements, group 1, group 2, are the what? Are the metals. We still have some other elements here. We have okay, let's say rubidium, cesium, francium is here. Then we have strontium here. We have strontium, we have barium here. We have radium here. Radium is 82. And this is 56. Of course, strontium is 38. Now, these 2 categories of elements are the what? Are the metals in the periodic table. The alkali metals, hydrogen is not a metal. That is why we said hydrogen is what? It's a category on its own. So from lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium, francium, radium. These are the what? These are the metals. Alkali metals, alkaline earth metals. Now the next category of element that we have are the what? Are the metalloids. The metalloid, or if you like, you can call them semi-metals. If you like, you can call them alkaloids, and if you like, you can also call them what? Semi-metals. So, where are the categories of these elements? Those are the elements that possess both the properties of metals and that of what? And that of non-metals. And of course, okay, here we can still have gallium here. You can have germanium. You can have indium here. You can have thallium here. You can have tin here. You can have lead here. We are trying to fish out the metalloids. Okay. We have selenium here, tellurium, polonium. Okay, we have antimony here. We have antimony. Okay, fluorine, chlorine, bromine, iodine, astatine. We have, after argon, we have krypton. We have krypton. We have xenon. We have radon. We have xenon, we have radon. Bismuth. Where is bismuth? Bismuth is 83. And arsenic will be here. Arsenic is 33. Why antimony is what? Antimony is actually 51. Because tin is 50. Tin is 50. Of course. So the metalloids. These are 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 the metalloids in the periodic table. Boron, silicon, germanium, arsenic, tin, antimony, bismuth. At times, polonium can be taken as what? As a metalloid. But polonium actually is a what? Is a radioactive element. Polonium is radioactive. We will get there. Where we'll be talking about radioactivity. That is what? The spontaneous disintegration of atomic nuclides. Leading to the what? To the emission of particles and rays. Such as the what? Gamma rays, alpha particles, beta particles, and so on what? And so forth. Good. These are the what? The metalloids. Of course, not to be mistaken, there are some metals in group 3 as well. We have some metals in group 3, such as aluminium. Aluminium is a metal. Aluminium is a metal. Aluminium is a metal. Now the next category of elements that we can